OSPF virtual links. This topology router with iOS 15.2. Instead of using serial 000, I will use serial 30, and instead of using serial 001, I will use serial 31. Three zero, 30, 31, 31. Start all devices. You are responsible for configuring the new network to connect your company's engineering, marketing, and accounting departments, represented by loopback interfaces on each of the three routers. The physical devices have just been installed and connected by serial cables. Configure multiple-layer OSPF version 2 to allow full connectivity between all departments. In addition, R1 has a loopback interface representing a connection to the Internet. This connection will not be added into OSPF version 2. R3 will have 4 additional loopback interfaces representing connections to branch offices. Required resources for a real lab. Suggested starting configurations. Apply the following configurations to each router along with the appropriate hostname. The exit timeout 00 command should only be used in a lab environment. Okay, no IP domain lookup to disable the domain lookup. On the line console, the login synchronous and exit timeout 00. This is insecure, but only do this on a lab environment. So you can apply this on all devices. Copy and R1, enter configure terminal, right click to paste, copy again, R2, configure terminal, right click to paste, R3, configure terminal, right click to paste. Okay, remember, set the host name for each device, R3, R2, and R1. Configure addressing and loopbox. Create loopbox on R1, R2, and R3 and address them according to the diagram. Also, using the addressing scheme in the diagram, apply IP addresses to the serial interfaces on R1, R2, and R3. Okay, on R1, loopback 1, 10.1111, the loopback theory simulates Internet and serial 30 on this network, 10.1.12.0, but assign first IP to a serial interface 3.0 on R1. Exit interface loopback 1, IP address subnet mask 24. The description says engineering department. Loopback theory simulates Internet IP address 172.30.31, subnet mask 252.30. Also, you can add the description Internet and serial 000. Okay, in my case, serial 30, the IP address 10.1.121, subnet mask 24. Set the clock rate to 64,000. This physical interface now shut down to enable. Now configure R2. R2 loopback 2, serial 30 on this network, 10.1.12.0.24, and assign the second IP. And serial 31 on this network, 10.1.23.0, assign the second IP. Exit interface loopback 2. Description marketing department IP address subnet mask 24. Interface serial 30. IP address 10.1.12.2.24. Enable this physical interface with the not shutdown command. Okay, and serial 1, in my case serial 31, the IP address 10.1.2.3.2.24, clock rate 64,000, no shutdown. Now configure R3. On R3, configure serial 31 on this network 10.1.2.3.0, assign the third IP, loopback 3, loopback 100, 101, 102, and 103. Okay, these four loopback interfaces on area 100. Exit interface loopback 3. Description, accounting, department, IP address. Loopback 100, IP address 192.168.101. Loopback 101, 101.1, 24, 102, 102.1, 24, loopback 103, IP address 103.1, 24, and interface serial 31 in my case, and the IP address is 10.1.23.3.24 subnet mask. No, shutdown. Now add interfaces into OSPF. Create OSPF process ID 1 and OSPF router ID on all three routers. Using the network command, configure the subnet of the zero link between R1 and R2 to be in OSPF area 0. Add loopback 1 on R1 and loopback 2 on R2 into OSPF area 0. The blue region includes loopback 1 on R1, loopback 2 and R2, and this network, the connection between R1 and R2, area 0. The default behavior of OSPF for loopback interfaces is to advertise a 32-bit host route. To ensure that the full 24 network is advertised, use the IPOSPF network point-to-point command. Change the network type on the loopback interfaces so that they are advertised with the correct subnet. Okay, change the network type for loopback 1 interface, loopback 1, IPOSPF network point-to-point exit. Go to create router OSPF process 1, set the router ID, and do show IP route connected to be the directly connected networks. This is the connection between R1 and R2, serial 3. This is the loopback interface on R1, both placed on area 0. Do not advertise this because this is internet, and only advertise the first two networks. Network 10.1.12.0 wildcard for 24 is this, and place it on area 0. And the loopback on R1 24 area 0. Okay, that is enough. The show IP OSPF command should be used to verify the OSPF router ID. If the OSPF router ID is using a 32-bit value, other than the one specified by the router ID command, you can reset the router ID by using the clear IP OSPF process command and re-verify using the command show IP OSPF. Okay, and show IP OSPF. Okay, and router ID 1111. Okay, if the router ID is not 1111, you should apply the clear IP OSPF process 1 command. Yes, then verify again, and the router ID should be this 1111. R2. Okay, on R2, remember, loopback 2 on area 0, and the network between R1 and R2 also on area 0. Exit. First of all, change the network type on loopback 2. Interface loopback 2 IP OSPF network point to point. Exit. Router OSPF 1, router ID 2. Do show IP route connected, and advertise loopback number 2 on area 0 and the serial network, and this network on the serial 30, but do not advertise this because it's placed on another area. Only these two networks. Okay. Wildcard area 0 and 12 10 1 12 0 area 0. The neighbor adjacency. Okay, now verify and show IP OSPF. And look at the router ID is this, so it's not necessary to apply the clear IP OSPF process. Again, the show IP OSPF command should be used to verify the OSPF router ID. If the OSPF router ID is using a 32 value other than the one specified by the router ID command, you can reset router ID by using the clear IP OSPF process command and re-verify using the command show IP OSPF. Verify that you can see OSPF neighbors into the show IP OSPF neighbors output on both routers. Verify that the routers can see each other's loopback with the show IP route command. Okay, go to R1, show IP routes. Look at this. This is the directly connected loopback 1 on R1. This is the loopback interface on R2. This is the network between R1 and R2, the serial connection, and this is directly connected network internet. Okay, show IP OSPF network. This is R2. And also go to R2, show IP OSPF network. This is R1, show IP routes. This is the loopback on R1. This the local loopback number 2, the connection to R1, this network, and this another network, directly connected network, the connection to R3. Add the subnet between R2 and R3 into OSPF area 23 using the network command. Add loopback 3 on R3 into area 23. Okay, now on R2, configure this network 10.1.23.0 on area 23. Okay, on R2, configure terminal router OSPF process 1 at that network. Okay, do show IP route connected this network. Okay, network 10.1.23.0 wildcard area 23. Okay, and now go to R3. Okay, change the network type on the loopback 3 and add the networks only for area 23. Okay, and R3 notify this loopback 3 and this network between R2 and R3 on area 23. Exit, interface loopback 3, IP OSPF network, point to point. Very nice. Exit, router OSPF 1, router ID, do show IP route connected. Okay, notify this loopback number 3, 10.1.30.24 from area 23, and notify this the connection to R2 10.1.23.0 area 23. Do not notify these networks on area 100 yet. Okay, do not for now, do not configure this. Then verify and show IP OSPF router ID, very nice, 333. Show IP OSPF network R2, very nice, and show IP route. Okay, OSPF inter area. This is the loopback on R1, placed in another area, area 0. Loopback on R1 on area 0. This is the loopback on R2 on area 0. Loopback on R2 on area 0. Directly connected network, loopback 3 on the local router, and OSPF inter area 10.1.12.0, this network on area 0. Also, a directly connected network, the connection to R2, and the loopback interfaces placed the networks of loopback interfaces placed on area 100. Okay, and go to create a virtual link. Add loopbacks 100 through 103 on R3 to R3's OSPF process in area 100 using the network command. Change the network type to advertise the correct subnet mask. First of all, change the network type on R3, configure terminal, interface, loopback 100, IP OSPF, network, point to point, 101, point to point, 102, point to point, 103, point to point. Exit, go to router OSPF1. Okay, and you can summarize the 100, 101, 102, 103 with each one with 24 subnet mask, and you can summarize this to only one supernet 100.0 with this wildcard mask 3.255 and place this on area 100. Okay, this supernet includes all networks 3 to 55 on area 100. Very nice. Look at the output of the show IP route command on R2. Notice that the routes to those networks do not appear. The reason for this behavior is that area 100 on R3 is not connected to the backbone. It is only connected to area 23. If an area is not connected to the backbone, its routes are not advertised outside of its area. Okay, verify on R2 and show IP routes. Okay, you can see the loopback interface on R1, the loopback interface on R3, loopback interface on the local router, the network between R1 and R2, and the network between R2 and R3. Okay, this, okay, but you cannot see this networks on area 100. What would happen if routes could pass between areas without going through the backbone? Routing loops might occur because any route could get advertised to different areas. By passing through the backbone, type 3 LSAs are generated by their respective areas and not sent back in. You can get around this situation by creating a virtual link. A virtual link is an OSPF feature that creates a logical extension of the backbone area across a regular area, without actually adding any physical interfaces into area 0. Prior to creating a virtual link, you need to identify the OSPF router ID for routers involved R2 and R3 using a command such as show IP OSPF, show IP protocols, or show IP OSPF interface. The output for the show IP OSPF command on R1 and R3 shown below. Okay, you need the correct router ID. For example, on R2, show IP OSPF. Okay, this router ID R3 and show IP OSPF. Okay, 3333. Now create a virtual link using the area transit area virtual link router ID OSPF configuration command on both R2 and R3. Configuration on R2 and R3. Go to R2 and configure terminal. Go to router OSPF process 1. On R2, on area 23, create a virtual link to this router, the router 3333. Okay. Area 23 virtual link 333. Okay. On R2, on area 23, create a virtual link to this router R3. Now, on R3, configure terminal, router OSPF 1, area 23, virtual link to router 2. Okay, on R3, create a virtual link on area 23 to R2. Now, you can see the adjacency. Notice after virtual links are established, iOS will report full adjacency between both routers. After you see the adjacency over the virtual interface come up, issue the show IP route command on R2 and see the routes from area 100. You can verify the virtual link with the show IP OSPF neighbor and show IP OSPF interface command. Okay, go to R2 and show IP route. Now you can see the networks on area 100. Inter-area 100, inter-area 101, inter-area 102, and 103. Okay, this is the loopback on R1, loopback on R2, loopback on R3, the connection between R1 and R2, the connection between R2 and R3, and networks on area 100. Show IP OSPF neighbor. Okay, you have 3 neighbors now. The first is R1 through the serial 30, R3 through the serial 31, but you have another R3 virtual connection with the OSPF virtual link 0. Very nice. Show IP OSPF interface. OSPF virtual link 0 is up and protocol is up. The network type is a virtual link. This is the IP address on R2 on the serial interface 23.2. This IP 23.2. And you are connecting to the backbone area 0. When are virtual links useful? Virtual links are useful when there needs to be a temporary extension of the backbone, either because the backbone became discontiguous or a new area got added onto an existing area. Why are virtual links a poor long-term solution? Virtual links are a poor long-term solution because they add processing overhead and basically extend the backbone area onto routers where it might not belong. They can also add a lot of complexity to troubleshooting. Summarize an area. Loopbox 100 through 103 can be summarized into one supernet 192.168.100.0.22. You can configure area 100 to be represented by this single summary route. Configure 3 the ABR to summarize this area using the area range network mask command. On R3, router OSPF1. Remember, R3 is the area border router, ABR. So R3 is the area border router between area 23 and area 100. So you can summarize this networks from 100 to 103 on R3. R3 exit and router OSPF1 area 100. The range will be 192.168.100 with this subnet mask 252 that includes 100, 101, 102, and 103. Now go to R2 and verify. Okay. Before you have 100 subnet mask 24, 101, 24, 102, 24, 103, 24, and now show IP route. You have only one network inter area 192.168.100 with subnet mask 22 that includes 100, 101, 102, and 103. Then also on R2 verify the database. Show IP OSPF database. The database, you can see this 192.168.100. Okay, the neighbor is router R3. Okay, this on area 0 and the summary net link states 100.0 from R3 on area 23. And notice on R3 that OSPF has generated a summary route pointing to our null zero interface. Go to R3 and show IP route, and you can see this OSPF 192.168.100.0.22 on null zero interface. This behavior is known as sending unknown traffic to the bit bucket. This means that the router advertising the summary route receives a packet designated for something covered by a summary but not in the routing table. It drops it. What is the reasoning behind this behavior? The reason that summaries generate local routers to null zero is that when a router creates a summary address, it should have routes to all the existent more specific routes. If the router lacks a more specific route for a prefix within the summary, it is assumed that the route does not exist, and packets designated for that prefix should be dropped. If the route did not exist, bandwidth could be wasted if this router has a less specific route, such as a default route, and forwards the packet to the route until it's dropped further down the line. The discard route also solves another problem. Depending on the contents of the routing table, a routing loop can be formed between two routers, one receiving a summary route from the second one, while the second one uses the first one as its default gateway. If a packet for a non-existent component of the summary route was received and there was no discard route installed in the second router, the packet would loop between the routers until its TTL was decremented to 0. Generate a default route into OSPF. You can simulate loopback 30 on R1 to be a connection to the internet. You do not need to advertise this specific network to the rest of the network. Instead, you can just have a default route for all unknown traffic to go to R1. To have R1 generate a default route, use the OSPF configuration command default information originate always. The always keyword is necessary for generating a default route in this scenario. Without this keyword, a default route is generated only into OSPF if one exists in the routing table. Okay, go to R1 and do this. Configure terminal router OSPF1. Default information originate always. Okay. This network simulates internet and show running config. You don't have a static default route configured on R1 pointing to internet. Show IP route. Okay, you don't have a static default route pointing to internet. So that's why I used the keyword always, because internet is connected to R1. Verify on R2, show IP route. Look at this, the default route pointing to R1, serial 30, and show IP route, the default route on external type 2 and OSPF pointing to R2. Okay, very nice. Now, you should be able to ping interface connecting to the internet from R2 or R3. R2, ping 172.30.31, success. R3, ping 172.30.31, success. Thank you very much.